Welcome to the deep dive. We're here to cut through the noise and really get straight to the core of complex topics. Today, we're plunging into SvelteKit. It's a web framework that's, well, really shaking things up. Now, for this deep dive, we've gathered insights from quite a few places. We're looking at developers on Reddit, talking about real-world stuff like auth, state, backend choices, and we've also got expert tutorials, some from Rich Harris himself, the creator, plus articles on using it for cutting-edge things like AI apps. So, our mission today: unpack SvelteKit's main ideas, find out the best ways to use it, and honestly explore how flexible it really is. I want to give you that shortcut, that clear path to understanding why it's becoming such a go-to choice for, well, pretty much anything from tiny projects to huge online stores. Get ready for some aha moments because this is where it gets really interesting. Okay, let's unpack this then. For those of us maybe more familiar with frameworks like, say, React or Vue, what exactly is SvelteKit? How is it fundamentally different?
Right. What's fascinating, I think, is SvelteKit's approach. It's quite unique. Unlike those traditional frameworks you mentioned, which, do a lot of their work in the browser, often using something like a virtual DOM, and think of it as like an extra blueprint layer. Svelte does things differently. It shifts most of that work to a compile step. That happens when you build your app, not when the user loads it.
A compile step.
Exactly. It writes code that directly manipulates the real DOM, the actual web page elements, surgically, you might say. That's why people call it the magically disappearing framework. After it compiles, there's basically no framework runtime code left in your final bundle.
Oh, runtime. Wow.
Yeah, and that directly translates to, well, incredibly faster load times and just better performance overall. It's a pretty big deal. And connecting this to the bigger picture, SvelteKit isn't just for UI components, it's a full application framework, kind of like Next.js is for the React world, right? It gives you server-side rendering, client-side navigation, a whole package.
Okay, so it's a compiler first, making things super efficient, and it handles the full stack out of the box. You also mentioned it's truly reactive. What does that actually mean for someone building an app? How does that make life easier?
That's a great question. Touches right on the developer experience. Svelte's reactivity is fundamental. It means when you change a variable, just a simple assignment, the UI updates automatically, instantly.
Without extra boilerplate code.
Exactly. No hooks, no special functions, just to link data to the view. You just change the value. It simplifies managing state, especially mutable state, a lot. Plus, SvelteKit apps use single file components. You get your HTML, your JavaScript logic and script tags, and your styles, scoop styles, mind you, all in one .svelte file.
Keeps things organized.
Very. That structure, plus its file system-based routing, which is super intuitive, makes it honestly pretty easy to pick up and really flexible for building complex multi-page apps without needing extra libraries for routing and such.
Okay, so we've got this powerful, fast, reactive foundation. Let's get practical now. What are the key building blocks developers actually use when they're, building with SvelteKit? How does it handle common stuff like fetching data or dealing with user forms?
Right, the day-to-day stuff. SvelteKit aims for a really unified experience here. It covers server rendering, client routing, getting data, changing data. For fetching data, the standard pattern involves using load functions. These live in special files like pluspage.js or pluslayout.js. What's neat is they can run on the server first for the initial page load, and then they can also run on the client for subsequent navigation.
Okay, so server and client side.
Yeah, but if you have data that absolutely needs direct database access, or maybe it contains secrets, API keys, that kind of thing,
Yeah.
to where you use server-only files, those end in server.ts or .server.js. So plus page.server.ts, for example. That code is guaranteed only to run on the server, never exposed.
Gotcha. That makes sense for security. Now, here's something I see discussed a lot. Data fetching strategies. Are those load functions always the answer? Or are there times you might just fetch data directly in a component, maybe using onMount?
Yes. That's definitely a key discussion point in the community. And it shows SvelteKit's flexibility, I think. Generally, load functions are recommended for what you'd call essential page data the page absolutely needs before it can even render properly.
Right, the core content.
Exactly. But onMount, which runs only on the client side after the component is first rendered, can be really useful for, say, non-essential data. Think maybe comments on a blog post or something that takes a long time to load and you don't want it blocking the main content. Fetching that async in onMount works well. The framework doesn't force one way, but for critical stuff, load gives you that predictability. The data's there before rendering. Helps prevent layout shifts, too.
Makes sense. And what about handling user input? Forms, submissions, that whole dance?
Forms are actually one of SvelteKit's real strong points. It simplifies them quite a bit. You can use something called form actions to post data back to the server. Often you don't even need to write explicit fetch code for simple cases.
Really? No fetch boilerplate?
Often no. It can handle updating the database and even reloading the page data automatically after a successful submission. It streamlines things a lot. Plus, it has built-in support for validation, both on the client and the server. And a really standout feature is progressive enhancement.
Progressive enhancement. How does that work?
It means your forms work even if the user's JavaScript fails or is turned off. Basic HTML form submission. But with JavaScript enabled, you can use a directive called use.enhance. This lets you intercept the form submission, handle it with JavaScript for a smoother UX like showing loading states or animations without needing a full page reload.
Ah, so it works for everyone, but gets better with JavaScript. That sounds like a massive win for user experience and accessibility.
It really is. It's robust.
Okay, so forms are good. What about state management? Especially as applications get bigger and more complex, does it get messy?
Good question. Svelte itself has powerful built-in tools called stores for managing reactive state across different components. And Svelte 5, the latest version, introduced primitives like state, which make reactive variables even simpler and more automatic. The UI just updates when they change.
So the basics are covered. But for large projects?
Right. For larger projects, to avoid what some devs call that confusing web of imports where you're pulling stores from everywhere, a common pattern is to group related stores together, maybe by feature or data model, or even organize state logic into classes that bundle the data and the functions that operate on it. Kind of like the SAM pattern state actions model.
SAM?
Yeah, state action model. It helps structure how things change, keeps complex state manageable, maintainable, and for any shared code, utilities, components, stores, the convention is to put them in the circlib folder. SvelteKit provides a handy alias so you can easily import from there anywhere in your app. Keeps things tidy.
Okay, that structure sounds helpful. Now let's shift gears a bit. Something very cutting edge. AI applications. Our sources show SvelteKit being used for some really interesting stuff here. Recommendation engines, interfaces for local AI models like Ollama. How does SvelteKit actually make these real-time interactive AI experiences possible? Especially thinking about things like streaming data back to the user.
Yeah, this is a space where SvelteKit really shines, I think. It enables a much, much better user experience compared to older approaches. Think about waiting for a big AI response, like from GPT-3 or something. It can take several seconds, right? Just staring at a spinner.
Yeah, it can feel like an eternity.
Exactly. SvelteKit makes it easy to stream the response back in real time instead.
So you mean like the words appear on the screen almost as the AI generates them, not just one big chunk of text after a long pause?
Precisely. It feels incredibly responsive, much more like a conversation. The user sees things happening immediately.
Wow, that sounds way better. How does SvelteKit technically facilitate that streaming?
It leverages its server capabilities. Typically, you'll set up your SvelteKit app with an adapter, maybe like adapter Vercel, and often enable edge functions by setting edge, true in your config. Then your API endpoint, probably a plus server.js file, sends the request to the AI service, crucially telling it you want to stream the response, usually a stream. True flag in the payload.
Okay.
The AI service then starts sending back data in small chunks, maybe just a word or a few tokens at a time over an open HTTP connection. A helper function on your server handles this stream. And then on the client side, this is where Svelte reactivity is key. You use reactive statements, the ones starting with syntax.
The $: thing.
Right. Those statements automatically rerun whenever their dependencies change. So as each new chunk of text arrives from the stream, you append it to a reactive variable. That variable change instantly triggers the UI update via the $block, displaying the incoming text bit by bit.
So the reactivity handles updating the screen piece by piece.
Exactly. And once the full stream is finished, you might have another reactive statement that takes the complete raw text and formats it properly, maybe into a nice list or adds titles, whatever the final structure needs to be. The same basic idea applies if you're talking to a local AI server like Ollama. You'd use fetch on the server to get a readable stream from Ollama's API, decode the chunks, and send them down to the client, updating reactive state. It's that incremental rendering that's the game changer.
That is seriously cool. Okay, so we've seen the core ideas, the building blocks, even these advanced AI features. But what about really big applications? I'm thinking like a complex online marketplace. Can SvelteKit genuinely handle that kind of scale? Or do developers need to start thinking about different architectures?
That's a very valid question, and the answer is yes, SvelteKit is absolutely suitable for large-scale projects, including complex marketplaces. I mean, look at who's using it or migrating to it. You mentioned companies like Apple, IKEA, Yelp, even the NBA and Yahoo Finance. These aren't small operations.
True, that's significant buy-in.
It really is. It speaks volumes about its capabilities. Their adoption suggests it's ready for prime time. For things like SEO, which is critical for a marketplace, SvelteKit does very well, especially with its server rendering and easy control over URLs. And that core benefit we talked about, no virtual DOM, compiling a way that leads to excellent load speed and runtime performance, which is crucial at scale. It's pretty tried and tested now. Security-wise, it's also got good defaults. It automatically sanitizes string outputs to help prevent XSS attacks. It has CSRF protection built in and enabled by default for forms, which is a big plus.
CSRF.
Cross-site request forgery, it's a common attack vector. SvelteKit helps protect against it automatically. And you can mark environment variables as private, ensuring secrets don't accidentally leak to the client-side code.
Okay, so it sounds pretty robust, almost like it can handle anything.
Yep.
Is there ever a point, though, for those really massive, complex systems where maybe using SvelteKit for the entire stack might reach its limits?
That's a nuanced point, and yeah, it leads to important architectural decisions. While SvelteKit can be your full-stack solution, and often is, for applications with extremely demanding back-end requirements, think really intensive CPU-bound tasks, heavy parallel processing, super complex data transformations, maybe massive file operations, Node.js, which is what powers SvelteKit's server side, might not always be the absolute most performant or efficient choice compared to other languages.
Like Go or Java, maybe?
Exactly. Some large enterprises find that for that real heavy lifting on the back end, it makes sense to build a separate, dedicated backend service using something like Go or Java or Rust, and then use SvelteKit primarily for what it truly excels at, building that fast, responsive, interactive front end.
A separation of concerns.
Precisely. It can make scaling easier, improve maintainability, maybe even enhance security boundaries for very large, complex systems. But it's important to stress Node.js itself and SvelteKit's integration with it has gotten much better over the years. And actually, something like a marketplace app, which often relies heavily on clear data flows, and that path-based routing SvelteKit does so well that's often considered particularly well-suited for SvelteKit's structure, even full stack. The absolute key, really, regardless of the stack you choose, is good architectural design right from the start. You want to avoid accumulating that technical debt.
Ah, yes, technical debt. That profitable code we feel afraid to change, as the saying goes.
Exactly that. Clean architecture prevents that fear down the line.
Wow, what a deep dive indeed. We really covered a lot of ground with SvelteKit, from its core philosophy that compile time magic and true reactivity, all the way to advanced features like real-time AI streaming. We've looked at how it handles auth, state, data fetching, and seen how it's proving itself capable for everything from small side projects right up to huge, high-performance marketplaces.
And we touched on that crucial architectural balance, right? Knowing when SvelteKit's full-stack power is the perfect fit, and when maybe, just maybe, separating the back end for those super heavy computational tasks might offer advantages. But the consistent threads seem to be flexibility, incredible performance, and a really developer-friendly approach to building modern web apps.
Absolutely. So thinking about all this, if SvelteKit lets developers build these incredibly fast reactive UIs and handle complex stuff like AI streaming with such, well, elegance and efficiency, what does this magically disappearing framework really unlock for the next wave of web applications? What stands out to you as maybe the biggest shift SvelteKit could bring, perhaps changing how we even think about building for the web in the